founding population. Zip it, zip it. Thank you. If this is my founding population, what color am I missing? Do I have full genetic diversity in this population of Skittles? I don't have any green Skittles. Do we know that green Skittles can exist? We do. We might not know it if we were only looking at this island. But sure, the genetic potential in the species includes green Skittles. But there are no green Skittles in the little island population that I'm starting off with. How do islands get populated? How do animals get onto islands? Well, they can get dropped off there by people. There have been instances in the Pacific where you have volcanic islands like Hawaii where people have actually witnessed logs floating in the ocean with lizards on them. Little lizards on logs floating, and they end up, if they're not lucky, they don't get anywhere and they drown and something eats them. If they are lucky, they wash up on an island. It could go either way. If they wash up on an island all by themselves as the only one of their species, do they populate the island? No. Because they need to have someone to love, or at least someone to mate with. So, if this is my founding population, do you think I'm going to have green Skittles on this island?
No.
No. The genetic diversity of the population is limited. By my what? Oh, by my founding population. Oh. Huh. So there are genes that could be present in the species that aren't present in this particular population because the founding members of the population didn't have those genes. So, who here had fewer than 10 individuals in their founding population? 2 groups. Okay. Did your population survive overall? Aww. So you went extinct?
Yes.
You know, small populations, it's a problem. Now, obviously, and it's interesting because we had one random group that went extinct and one selective hunting group that went extinct. Small populations, often over time, don't do so well. It's hard to maintain a small population over many generations. Who had the biggest populations here? We had, what, 22? You guys had 18? Anybody else have more than 15? More than 15? Okay. Now, you guys didn't face extinction, did you? Did you end with a pretty robust population? You had lots of Skittles at the end. You are satisfied with the number of Skittles you got to eat, I hope. Okay, how many did you have in your starting population? 10, and you guys had 13? Okay, so kind of middle-sized populations. And again, one random, one selective. Did either of you face extinction at the end?
Not even close.
Interesting. No, you guys, your Skittles were doing very, very well. But let me ask you this. If we think about an actual organism, okay, so for my random predators, you guys were random. Oh, did both of... Yeah, you guys had a large population. You were random. Did you start out with all your colors? Did you end up with all your colors? You maintained all the colors throughout the whole thing. So no, you didn't lose any genetic diversity in your population. It's not like suddenly all your green went extinct. Okay. Did you guys start off with all colors?
Yes.
Yes.
Did any of your colors go extinct?
Yes.
2.
So you lost some genetic diversity from your population. Oh, you actually got down to just 3 colors. So your population afterwards was less diverse because you were selecting things and eating them. Did you guys start out with all the colors? Did you maintain all the colors you did start out with? So you lost and you were random and you did lose some colors. So Logan, how many colors did you guys start out with? How many colors? 5. All 5. Okay. Did you have all colors left at the end? No. And you were selective, correct? So you were selecting certain things to eat. Interesting. Interesting. Well, I want to jump back to something we talked about a few days ago. And as I said, you're not going to get to answer all these questions today. You're going to have to keep these for a couple of days. I know, it's terrible. I want to talk about this. Blue-eyed mutants.
Oh, it's me.
Yes, yes, my little blue-eyed mutants. What would be the analogy for our little island population of skittles to blue-eyed mutants?
Rare.
What if suddenly in the next generation a yellow skittle gives birth to a green skittle? What would that represent? A mutation. Suddenly we have an option that didn't exist on that island before. It means that we've had a mutation, and a major enough mutation that we have a characteristic that didn't exist in that population before. Can it happen? Yes. Okay, I'm going to ask you again. Who are my chicken people in here who have chickens? I had those pretty little barred rock chickens on the first page. And they're beautiful because they've got sort of broken colored feathers. They're black with little white stripes. That is a mutation. And we'll talk more as we talk about artificial selection about, does anybody here actually have Java chickens? Nobody has Javas. Okay, never mind. Never mind. So let me ask you this. If you had started off with full color and one color went extinct, if we allow for the possibility of mutations in your population, could that color reappear? Yeah. If the genetic potential is there in the species, it's possible. But if the only person carrying the genes for that color dies off, how likely is it? We don't know statistically. We don't have numbers. But it becomes less and less likely the smaller your population is because you've lost so much genetic diversity. You've lost potential. I should have actually had you document. So migration. You guys had, all your skittles went extinct. Some skittles emigrated from this island and immigrated to your island. What did that do to the genetic diversity on your island? You had no genetic diversity because you had no genes before. What did that do when I dumped some skittles on your desk? Increased your genetic diversity. So you had new individuals come into your population. I could have done that when you had only 2. Suddenly you have more genes. When a new individual enters the population, they bring their genes with them. That increases the genetic diversity in the population they go to. What happened to, who did I steal from? I stole from you guys and you guys.
Correct.
What did that do to the genetic diversity on your island?
Broken.
It decreased it. Suddenly, maybe I took your last red. I don't know if I did or not. When those individuals left your island, and these are notes, when they left your island, they take their genes with them. They decrease the genetic diversity that's on that island. And just to note, it doesn't have to be islands we're talking about. So this is, there's a beautiful movie. I would recommend you watch it if you can find it. It's about wild horses, and I know I have a few horse people in here. Okay, so there was a PBS documentary done a number of years ago. This like 60-something-year-old lady would pack up about 60 pounds of filming equipment and hike up into the Rockies to 13,000 feet with all her gear on her back and stay for days and follow packs of wild horses in the Rockies. Not for the faint of heart, but really, really cool. And look at the variation in those guys. A lot of dark horses. There appear to be a couple lighter horses back here, but they all have dark manes. And then up shows, and what did she call him? Cloud, I think. She named them all in her head just to keep track of them. And he's this very pale stallion. He shows up in this population of wild horses. There's a particular herd of wild horses that she's following in a particular area. It's a population, they're interbreeding. And he manages to work his way into this group. And guess what was true a couple years later? Because he was apparently a very attractive stallion to the mares in the group, and apparently was able to compete successfully for mates. Guess what they had a bunch of in a few years?
Stallioness.
very pale, younger horses who clearly had some of his genes. When he immigrated to that population, he brought his genes with them. He increased the genetic diversity in their herd. Now here, I guess I've got it drawn the opposite way. What would happen if he took off? You suddenly lose those genes. Now, as it turned out, he did well. He was successful. He left some little pale baby horses running around carrying his genes. But it can happen that we have new genes come into a population, and it really changes how that population looks over time. That is because when individuals enter a population, they increase the diversity in the gene pool. They bring new genes into the gene pool. When individuals leave a population, they take their genes out of the gene pool. One increases the genetic diversity in a population, and the other one diminishes it, it decreases it. And the gene pool is all the genes that exist in a population. How many of you have heard the expression gene pool? Okay, did you know what it meant? Okay, so it's all the genes that are possible in a population. We will stop there. I'll let you finish up this slide. Tomorrow we're going to keep going. You're going to have to hang on to that Skittles packet all week. And the other thing to tell you is that tomorrow I will have class codes for you based on your Friday groups. I'm going to have you join a Google Classroom for your Friday group. Makes it easier for me to post stuff, and you can communicate with one another there. So that's all we got for today.